on the general importance of trust in the concept of AI systems of many forms. During this panel, we're actually going to hear from the people who picked the specific topics that are being funded and who led the evaluation of the proposals for those topics. We had many, many proposals, selected the awardees, and are going to be working with people on an ongoing basis of the various work that we're funding through these several processes. We've actually used 3 separate processes in making awards. There was first a process that was developed here at Rome Labs along with their partners that's funding essentially basic research on the topic of trust in AI. There's a second set of awards in the STTR program, which are university industrial partnerships. And there's a third set of awards under the SBIR program, which is industrial work, sometimes in partnership with government labs or academia, but whose primary goal is to deliver tools to commercialization. And we're going to hear from all those people. The format of this is going to be a brief presentation about what the topic is by each of the authors, and then a short discussion with a question that I'm going to raise to make this more of a conversation than a series of 9 presentations in a row that we're a little afraid might bore everyone to death. So without further ado, let's start with Dr. Laura Steckman, who's a program officer at the Air Force Office of Scientific Research, who's going to talk about her topic, which is the one most focused on basic research in the area.
Yes, hi, good afternoon, everyone. So I am Laura Steckman from the Air Force Office of Scientific Research, and I manage the program Trust and Influence. So today I'm going to talk with you about one of the topics for the Trusted AI Challenge, which was the earlier effort that Dr. Friedland just spoke about. So this particular topic was developed in collaboration with the Information Directorate and the Human Performance Wing and AFOSR to try to think about what trust should look like in the future. We spent a lot of time talking about human-machine teaming, but this topic, and I should give you the title, is Human Artificial Intelligence Performance Optimization, Trust and Joint Action for Digital Data Analysis. So in the construction of this topic, and it would take a while to unpack all of the different pieces, while we were talking about topics and working to write them, the inspiration for this actually came from the US Space Force, where Major General Kreider was talking about Space Force as a digital force. So thinking about human-machine teaming and human AI and what that might look like for the future, this particular topic is considering trust to increase performance in a joint action setting where a human and a machine or a human and an AI agent may have completely different missions, but they must cooperate together to perform some task or accomplish something, and they go back off on their separate ways. How do you create that trust swiftly, and how do you do that in the context of a digital force? So that's the genesis of this topic, which came about after quite a few conversations with my colleagues at RI and RH. Right, so I can go back to Peter. So the literature shows right now that trust in human-machine teaming and human autonomy teaming increase performance, not necessarily the other way around. So at least in theory, the way the literature looks right now, trust should increase performance in human AI interaction. So that is one piece of this topic. The joint action, again, is where the human and the agent will have different tasks, but they'll have to cooperate versus collaborate. Although in theory, and part of the magic of basic research is that these efforts may then apply to a human-machine teaming as well. So that is one of the really great things about working on these topics, and you'll hear tomorrow from the presenters and the selectees for that particular challenge as they talk about their research. Beyond that, we had a number of wonderful proposals that were submitted. It was a great pleasure to read them, look at all of the creative approaches to digital data analysis, from the really traditionally focused kind of intelligence analyst type perspective to even one really excited that you'll hear from tomorrow, who's bringing neuroscience and quantum cognition into the study of trust.
Thanks, Laura. For those who are wondering, Laura is not actually on the space station. She just wishes she were. And as Laura also mentioned, tomorrow you will be hearing exactly what were the specific proposals in all of the categories that actually are funded. Laura, so from the basic research side, what do you see as the transition pathway to making sure that the fruits of what you're funded actually have an impact in the relatively near term on the Air Force? In other words, how are you going to be getting those folks to work with people in the more applied areas?
Well, so that is a great question, Peter. Thank you very much. So first of all, I think the collaboration we now have established between the different technical directorates is going to be very helpful. I know all of us have talked about being involved with all of the different levels and efforts, and so I think that sets us up for a really good start. From there, one of the things I try to do is bring stakeholders in as early as possible and as often as possible to see what the progress is. And yeah, so those are the places where I think we should start for that transition, kind of sharing what is learned. Yeah, I could tell you about some of the successes in the program right now, but that would take us a little bit away from the point of this conversation.
No, thanks, Laura. Our second speaker is going to be Dr. Sarah Bibic of the 711th Human Performance Wing at Wright-Patterson Air Force Base, and she's going to be talking about one of the two STTR programs. Sarah?
Yes, thank you. Can you hear me?
Yes.
Yes, well, thank you very much. I'm happy to be here. Like Peter said, my name is Sarah Bibic. I'm a research psychologist in the Airman Systems Directorate in the 711th Human Performance Wing at Air Force Research Laboratory. So my background is in both cognitive science and linguistics, and my research interests have always been in understanding the processes that allow us as humans to effectively communicate with one another. Now, one of the absolutely essential components of effective communication is the integration and management of what is known as the common ground. And this is the shared beliefs and knowledge which are relevant in the current context. So to establish, maintain, and repair common ground as needed and on the fly in real time for human-human teams is no small feat. And to do so within human-machine teams presents an enormous challenge for our current AI systems. There are numerous obstacles to the integration of common ground in human-machine team conversation, including but not limited to the need for further development in natural language processing and understanding, the need for further development in knowledge representation systems, the need for further development in flexible and adaptive AI learning mechanisms, but aside from these challenges, there's also still a real need for further research into the human processes which underlie common ground maintenance, and whether and how such processes can actually help overcome some of the challenges that I just mentioned. The need for this research is the reason for SITR topic T002, establishing common ground between humans and machines, on which I am the technical point of contact. This topic was also developed as a collaboration between the Airman Systems Directorate and AFOSR. So to develop AI systems that can establish, maintain, and repair common ground on par with their human teammates requires research in a number of areas. This includes further codification of conversational and cognitive processes related to the integration of common ground. It includes the validation of metrics of both successful and unsuccessful uses of common ground during real-time conversation, and it includes the development of computational models of these processes. Additionally, future research needs to explore the role of different kinds of language communication on these processes, including both natural languages and also non-natural or controlled languages. So this is a topic that I am very personally invested in my own research. I saw many good proposals yesterday on this topic, and I look forward very much to the output from their submissions. And I'm happy now to turn it back over to Peter for questions.
Thank you. And one thing that everyone should notice, and in fact, it was mentioned by Dr. Lugensland in his talk a little while ago, these topics involve many different types of sciences. And you'll see represented among the group here, computer scientists of various type, cognitive scientists, experimental psychologists, and the like. And I think that's one of the things that makes this area particularly interesting to many of us, because it is so interdisciplinary. So, Sarah, when you talk about common ground, what are your thoughts on how cultural differences affect that?
Oh, that's a very interesting question. I mean, it's a good question, certainly. I mean, it's a challenge. To be honest, there's still so much we don't know that well about how people from the same culture are able to establish common ground. I mean, situations I've seen in experimental paradigms where honestly it seems like magic sometimes, that people are able to just integrate all of this information from their prior knowledge and knowledge that they have about who they're talking to and the other speaker. And so then when you try to apply that to cultural differences, how do we manage these issues when you have like some sort of cultural differences between how the cultures go about addressing various aspects of communication or teamwork? I mean, that it's just it's astronomical, the amount of variables that you have to consider. So it's a very, very important topic to consider. It's going to be a very important part of our research going forward, especially for teams that are international teams that are not co-located. And so even there's a lot of this foundational work that we still need to do in addition to that before we even are able to address some of those very large and very important questions.
Thanks. Yeah, and I would point out one very interesting document that people might want to look up is Dr. Mayberry, who I hope most of you heard yesterday when he was chief scientist, led a document called Global Horizons, which pointed out the importance of the Air Force's investment around the world in research. And for those like myself who are particularly interested in that international outreach, it's a really good document. You can find it just by Googling Global Horizons on the web. Our next speaker is actually 3 of the 8 people that Denise referred to. Dr. Alvaro Velasquez of the Information Technology Directorate here. He didn't have anything else to do, so he actually has 3 separate topics here, 1 of the STTR topics and 2 of the SBIR topics, and he's going to talk a little bit about all 3 of them.
That's right. Thank you for the introduction, Peter. So the first topic is on hierarchical heterogeneous planning. And the crux of this topic is that a sort of precondition to establishing trust, I would say, is having a common language between the operational experts and our SNEs. And that's something we don't currently have. And what do I mean by a common language? I mean some mathematical abstraction of what the problem is, such that if you present it to somebody, there is no doubt about what you're talking about. So I went to Air Mobility Command last week, and that's when I realized just how pervasive this problem is. I thought I understood airlift. I thought I understood maximum on ground. I thought I understood all these things. Turns out I had no idea. So we need some kind of mathematical model by which we can reason about these problems, not just so that we have a common language across operators and SNEs, but also so that we can adopt existing solutions in AI. So as a simple example, if you take maximum on-ground problem, it's a simple problem. You have a set of aircraft, you have a set of airfields, you want to pack all of these aircraft into as few airfields as possible, right? Now, if you try to mathematically formalize this, you quickly realize that this is a very famous operations research problem known as bin packing. Why do we care? Because we know that bin packing is NP complete, so we know it's not likely to admit some efficient solution. We know that there are good approximation algorithms. We know that there are good heuristics. We know all kinds of results over the past 40 to 50 years. All of a sudden, we can bring all that academic and private sector knowledge into our Air Force problems. So I think it's very important that we look into this, not just for MOG, of course, for maximum on ground, but for heterogeneous domains. Of course, we're trying to reason about joint all domain systems. We want to reason about land, air, cyber, space simultaneously. How do you mathematically abstract the heterogeneity of these domains and also abstract the hierarchical nature therein?
Okay. Yeah, I mean, the issues of planning and scheduling are ones that many of us have been working on for many, many years. My own PhD research was that back in the 1970s, back when we used steam-powered computers. But I was wondering, Alvaro, where do you think are the key issues relating to trust that you've seen in the planning and scheduling domains as you've looked around?
So I think, so this is certainly can be looked at in 2 directions, a good old-fashioned AI perspective and a more modern machine learning perspective when it comes to planning solutions. Trust in machine learning is something I'll cover in the other 2 topics, but from a good old-fashioned AI perspective, it's already so amenable to an explanation. If we look at, again, maximum on ground, you might define a mathematical formulation where there's a variable xij which equals 1 if aircraft I is assigned to airfield J. So from a simple mathematical formulation, you already have the semantic meaning within the variables themselves. So I think this is perhaps the lowest hanging fruit in trustworthy AI.
So you're saying the trust in this case would evolve from showing the mission people that there was a provable solution to their problem, right?
Exactly, with semantically grounded variables, which is what we get from good old-fashioned AI, of course.
Okay. I don't know about the old-fashioned part, but yeah.
Sure.
Next topic.
All right, next topic is explainable decision-making. So, of course, one of the obvious conduits to trust is having a learning system actually provide an explanation of its learning outcomes, right? We've seen a lot of success in this area in recent years. The DARPA XAI program had a tremendous success, I would say. A lot of papers came out of that. But most of the papers looked at sort of your conventional machine learning, your classification problems, is there a face, is there a dog, is there a cat, and your regression problems. And that's all well and good, but when you consider the decision-making problem, there are at least two very big challenges that preclude some of the solutions that were derived in the past few years. First of all, it's the fact that an agent can change its future observed data distribution through the actions that it takes. You don't have this in classification, you don't have this in regression. A simple example is if your blue aircraft shoots down an enemy aircraft, you're not going to see that aircraft again. So by changing the future data distribution, you have to reason about that within the derivation of an explanation of learning outcomes. And then the second challenge is, of course, you're reasoning about some kind of long-term objective. This is very different when compared to classification and regression, where you know the objective immediately. Was there a face? Was there not a face? Here, it may take many actions before you actually achieve your outcome. So both of these things bring significant challenges to the explainable decision-making setting, and that's what we hope to resolve within this topic. So
do you have any ideas about what innovative ways of explanation you're looking for in what you're trying to fund here?
There are some exciting avenues here. So things like causal networks, for example, learning a causal network explanation of decision-making, learning an automaton, some kind of formal linguistic structure, right? We have the famous Chomsky hierarchy of languages that can be used for this. You have deterministic finite automata for regular language, context-free automata for context-free languages, and so on and so on. These can actually be learned in the same way that the learning parameters of a neural network are learned. As you collect more and more traces of behavior, you can learn these structures. I think that would be a very exciting way to explain these systems.
Do you think that, as came out of part of the XAI program, there might have to be sacrifices in speed and performance to get explainability?
That seems to be the case. I was reading a paper recently on adversarial explanations, where you actually bring explainability into the loss function of a learning model. And what you get are actual explanations that humans can understand, but you take a loss in performance. So it seems, of course, there's always a trade-off, right? There's always a balance to everything in the universe, it seems. So I think there will be some trade-off between performance and explainability.
Okay. And your third persona.
My third one. Okay.
You should really be changing, taking
doing
something.
Putting on glasses.
Yeah.
So the third one is transfer learning for control policies. This one is motivated by a few things. Perhaps a lot of you on the call will be familiar with all the advancements in reinforcement learning and planning, where you get systems that have superhuman performance in various domains. This started in 2013, superhuman performance in Atari. 2016, the defeat of the World Go champion. 2018, AlphaStar defeated StarCraft 2 champions, Dota 2. There are so many examples. And of course, we want to adopt some of these systems. There are significant analogs between these systems and our own problems. For example, StarCraft 2 is a real-time multiplayer strategy game. A lot of our campaigns that we could simulate look similar to this. But the problem is, these require a tremendous amount of data, sometimes hundreds of years worth of data. And when you look at our modeling and simulation environments, things like AFSIM, things like ALSIM, they run on the order of minutes to hours. And it's clear we're not going to be able to run these things for millions of hours. So what solution is there? We can turn to computer vision and natural language processing communities, where transfer learning has been tremendously successful. If, for example, you want to classify some sensitive military aircraft, you don't have enough data, but what can you do? You can pre-train over ImageNet, and then you can fine-tune your learning model over your sensitive data. That's an example of transfer learning. So the question is, can we do that within the decision-making problem? Again, we face the same two challenges that I discussed in the previous topic, the fact that agents change the future data distribution and must reason about some kind of long-term objective. So here the question is, what is that transfer learning mechanism, and how do you measure the similarity between two modeling and simulation environments, so that perhaps we can come up with some alternative to AWESIM while still having effective performance within these high fidelity environments we already have?
So within the transfer learning paradigm, is it mostly an issue of, almost entirely an issue of trustworthiness of the AI system, or do issues of human-machine partnership enter into the equation?
There are issues with both. My concern from a trustworthy AI perspective, when we try to perform reinforcement learning over our existing high fidelity sims, is that they're so slow that, first of all, I would say it's intractable to run a lot of the state of the art. Second of all, as soon as we bring in an explanation, it becomes even slower. This goes back to the trade-off we just mentioned in the previous topic. What I hope is that by coming up with some surrogate environment where we learn, we might be able to not just learn effective decision-making policies that we transfer over to high fidelity sims, but we might learn the explanations in that surrogate environment as well.
Okay. Okay. Our next speaker, also from the Information Directorate, is Mr. Stephen Drager.
So the assurance of trusted AI ML systems is really looking at, as a designer, as a systems integrator, how do I analyze, architect, build an evidentiary trail so that in the end I can prove to a airworthiness team, to a certification authority, that my system, including its AI components, is predictable and can be safe in its use in the field. So this is throughout our research prior to the topic, we've had discussions with Boeing and with the FAA, and this is something that's going on right now. How does the FAA allow AI type of systems in their national airspace, and what are the types of analyses that needs to be done during that architecture stage, during that design stage, to provide that certification package, so that the humans can go in and say, yay, let's fly in our airspace, we're not going to harm humans, there won't be property damage, those types of things. And so we're looking for those types of tools, those types of analyses that provide those types of documentation as we're in our architect all the way through design and implementation phases of the software project.
So one of the things we've seen, particularly in the aerospace domain, in recent very well publicized accidents, are issues where, in theory, the software was validated beforehand, but humans weren't properly trained in the use of it. So the issue of the human-machine teaming became a major problem. So have you thought about that at all as you think about the process of the people you've dealt with within the aerospace system?
So we actually had some research several years ago under the DARPA A-Teams program that was looking at how to have teams of AI and people build the software system, train the software users into the field. It kind of ended prematurely without real end results, but there have been other efforts along the way since then, such as the Explainability program and others, but it all hasn't necessarily been fed back together into an end result like the A-Teams program was trying to have. But it seems to be that the technology's matured enough where, especially from the training, especially from the team usage, we should be able to at least document those instances and make it clear in the training procedures where those instances of ambiguity might occur.
Okay. Great, thank you. Our next speaker is Captain Matt Ruden from the Air Force Life Cycle Systems Center. I believe he's officially part of, I love the term, the Digital Directorate. So Captain Ruden, over to you.
Yes, thank you, sir. Good afternoon, ladies and gentlemen. I am Captain Matt Ruden, Chief Innovation Officer for PEO Digital. Don't let that duty title impress you. As I like to tell my team members and colleagues, I don't have a monopoly on innovation. I rely on some really smart people to guide me on new processes and technology to enhance our mission effectiveness. And those smart people wrote the emphasis areas for this topic. I want to say a very big thank you to the teams that submitted proposals to our AI Pitch Day. I know proposal development takes some serious time and effort, and we wouldn't have been able to have the event without your participation. We had some tough decisions to make, and we received a lot of promising proposals. The topic I'm representing is a little different than the other topics you'll hear about today. We're taking a look at several very different mission areas across 2 directorates where we think artificial intelligence can make the most impact. One of our divisions, Force Protection, is looking to leverage advanced computer vision and AI algorithms to analyze real-time video feeds to detect and classify threats. For example, we can create virtual restricted areas using existing surveillance cameras by analyzing video feeds in real time and using computer vision to classify objects, examples, a vehicle, a human, an unmanned aerial system, a bird, etc. And then generate alerts when a possible threat, like a human or a vehicle, crosses a restricted area's perimeter. In another division, Aerospace Systems Management, we're looking to use AI to improve safety assurance through optimized airspace management. Example desired outcomes from this would be having aircraft more closely spaced, increasing sortie generation, or permitting more aircraft to follow optimal routing. Those are just a few examples of what we're trying to achieve with this topic. I want to invite you to visit our virtual booth for the Digital Directorate within the Partners tab to see a video that showcases what mission areas and technology we're using today that's being advanced by artificial intelligence. Thank you for joining us today, and I hope you enjoy the panel. Back to you, Dr. Friedland.
So Matt, your topic is a very broad one, obviously, with lots of interesting stuff. I'm just curious, how in the world did you differentiate? How did you find the most interesting ones? Was it solely by quality of the proposal, or did you pick a few emphasis areas that you thought would have the greatest impact on the existing Air Force or Space Force?
So that was a tough balance we had to make, and I wish my lead evaluator was here to help answer that, but it was basically having to make a decision between the combination of where would this make the most impact within our portfolio, and also how strong was the proposal. So we had to weigh those two when we were looking at what would fit best within our topic area.
And how did trust enter into the equation?
I'm sorry, what?
How did the issue of trust enter into the equation?
I'm sorry, I have to get a SME to help me answer that.
Okay. No problem. Okay, so let us go on now to Dr. Chris Myers, who is also of the 711th Human Performance Wing at Wright-Patterson Air Force Base, on his topic.
Thanks, Peter. So as we've heard over the past couple of days from all of the excellent speakers who've come before, the establishment of trust within human-machine teams is a critical component of the future Air Force systems, where warfighters will continue to be partnered with increasingly intelligent machines in order to outwit and outpace our adversaries. So a collaboration between the Airmen Systems and Information Directorates, along with the Air Force Office of Scientific Research, work together to develop a topic centered on an intersection between two research domains important to the U.S. Air Force. So one is human-machine teaming, and the other is training. So today, all human teams train together to better accomplish their common missions through improved communication and coordination, but they're also able to identify the strengths and weaknesses in their team members' capabilities. And this helps to identify which team members should perform what and when in order to push performance to its maximum, turn it all the way up to 11, if you will. So as machines become increasingly intelligent and capable, the ability for them to partner with human team members during training will provide each with opportunities to experience the other's strengths and weaknesses. And in turn, this will help to calibrate trust in each other's capabilities and determine who, and in this instance, which human or machine, should do what and when. Today, co-training with artificially intelligent systems is a challenge, and the topic that we pulled together seeks to address this challenge. And so specifically, the topic is focused on the research and development of behavioral models, methods, and metrics for the establishment, maintenance, and repair of bidirectional trust during human-machine co-training. So behavioral and cognitive models are important in identifying limits on human information processing, theorized and demonstrated to be critical to the establishment, maintenance, and repair of trust, as well as performance. Methods for co-training are critical for determining which approaches are best suited for appropriately calibrating trust and improving human-machine performance. And finally, the third facet of the topic are metrics, without which we wouldn't have any particular way of judging the benefits of the methods or the models as they're pushed into the systems within co-training environments. And so they're also, and to be specific, they're critical to capturing the dynamics of trust, establishment, maintenance, and repair to better assess the trust relationship to and influence on the team's performance. And with that, I'm gonna wrap up. But before I do want to say thank you to everybody on the team who has helped make this whole thing possible and providing us with an opportunity to pull together research agendas that are useful and beneficial to the goals in our respective directorates and to establish cross-directorate opportunities to push this research with industry. So thank you.
So Chris, the issue of co-training is certainly an interesting one that you guys, I know, have been studying for many, many years. Also, as you know, there's been an emphasis in the field of AI in the view of what's often been called life cycle learning. So how do you envisage the issue of, past the formal training process, the kinds of additional training or learning, or whatever you call it, that occurs as teams actually perform together? So it's not their official training thing, it's their doing operations in the field, wherever, and how they improve their knowledge for the next mission as part of what you might call a life cycle of training processes.
Yeah, that's a good question. And there's some technical challenges that we need to jump over. But before I get there, we can currently train with automation. So we do this all the time. But as machines become increasingly intelligent and autonomous, the challenge here is getting our head around how the types of decisions they're going to make under the particular context, as Dr. Coleman pointed out in her brief. The challenge with training and then moving to the operational setting is the ability to serialize or provide a more permanent set of learned information and knowledge based on decisions that have been acquired in the field. So in our training situations, we tend to have a pretty well controlled environment to push on particular things we're not very good at. And it would be fantastic if we could pull the same type of data from our operational settings that we do in our training settings. a particular tactic didn't work under particular contexts, we can then pull those data and work towards improving the human-machine teaming in those particular contexts. So I think it's a real challenge with respect to acquiring the data and instances of failure in an operational setting over a human-machine team's lifecycle.
And then last, but certainly not least, we have Dr. Joseph Lyons, also of the 7th and 11th. We'll talk about the final SBIR topic.
Great. Well, thanks, Peter, and good afternoon, everybody. So I'm going to be talking to you today about the life cycle approaches for transparency. And so first of all, what is transparency? I view transparency as a set of methods to establish shared awareness and shared intent between humans and machines. And so a key element of that is the idea of methods. It's more than one. So thinking about transparency, one's instantiation of transparency should incorporate more than one element of transparency. And this is motivated by the idea that systems go through a life cycle. They're designed, they're tested, they're implemented at multiple phases, they're implemented with multiple kinds of users, and they have a long life cycle at that point. So it's the idea of trying to think about transparency across that life cycle and how we can use different elements of transparency at different times. And I think Dr. Coleman said it best when she talked about if we're aiming for effective human autonomy teams, we need to have shared models of the world and shared models of one's role in that world, which are two separate things, right? So how do we get there? And why is transparency so important, right? So if we're going to give autonomy, if we're going to give decision authority to machines, to AI, we need to be able to have some understanding and prediction of those systems and what they're going to do in different contexts. So we need to understand their intent, their rationale, their assumptions. Are their assumptions the same as our assumptions? And if they're not, that's another way to promote transparency, to say, hey, the system thinks one thing, you as an operator might think something different, or as a tester. And we need to have some prediction of what's going on with those systems in these different contexts. And so yesterday, Dr. Mark Mayberry noted that we need to have verified and trusted relationships between humans and AI systems. And I believe transparency can be one way to facilitate this, but we need to move beyond the task execution phase of where transparency is most commonly used within our operations as a way to look at kind of the task execution portion. We need to look both before and after that task execution phase to say, hey, what's going on before, what's going on after the task, to really understand and predict what's going to happen with our systems. And this is similar to how we view trust of humans, right? So when we're considering trust and basically ways to predict the behavior of other humans, we don't typically look over their shoulder and say, what are they doing right now? Are they doing the right things at this moment in time? I mean, you might have a supervisor that does that. It's not a very effective strategy. So typically what we do is we consider things like education and training. What do they know? Where did they learn? What are their affordances for knowing that knowledge? What's their past performance look like? Where did they perform? What are the contexts within which they performed those different tasks and whatnot? What's their reputation socially and in a task context? Looking at their past behavior, have they been supportive? Have they been proactive? Are they attentive to details? And also, how do they explain mistakes? Are mistakes explained in a way that's acceptable to us to say, I have some confidence that this person is going to perform well in the future situation. So these are all ways that we can approach the problem of transparency. And again, the whole motivation behind this particular SBIR topic was to think about transparency as more than one thing applied across the life cycle of an AI system. And with that, I'll turn it back over to Peter. Thanks.
So you talked, the issue of transparency is certainly a very interesting one. What are your thoughts about transparency in the other direction, of the machine agent understanding the beliefs, desires, intents, the theory of mind of its human partners, of the humans being transparent to the machine agents in the team?
Absolutely. So what you're talking about is what we call bidirectional transparency in the research community. This is a concept that was popularized by one of my colleagues, Dr. Jesse Chen, in the Army. And it's a very important idea that we need to think about. It's not just about the robots or the AI sending information to us. It's also about the systems understanding information about us as humans. And there are many challenges from a research standpoint in doing this. So the first one just involves merely sensing. What do we sense in the human to convey information to the system? Secondly, how do we augment the human? Once we have sensed that information, how do we use that to augment the human in that particular task context? And finally, how can we understand humans' acceptability of that, not only sensing, also the augmentation that comes within these AI systems? So if we're going to have intelligent systems that interact with us adaptively and they understand our maybe it's our physiology or some other state facet about our performance or fatigue levels, we're going to really need to understand how humans accept and trust those sensing and augmentation strategies as well. Very good question, Peter.
Yeah. Well, so in what I believe is unique in my career, 9 virtual scientists and 7 actual ones have actually kept on time in a procedure. So we actually do have some time for some additional discussion. So let me kick it off, but I'd like everyone else to think about things to ask of your fellow forum members. So let me kick it off with the question. I know one of the reasons why all of us have spent a lot of time and trouble with this effort is because we view it as not just a way to get money out the door to a bunch of places, but are trying to build a continuing program in this area of human-machine trust. So I'd like some people's thoughts on how we're going to make sure to do that. So it's not just a one-off effort. And I'm going to turn first to, I'm going to first pick on Chris, because I've heard him actually speak fairly eloquently about how to proceed. But I'd really like to get more than one person's opinion about how we're going to make sure going forward that this actually is a program of use to the Air Force, Space Force, and the larger community, not just proudly saying we got a bunch of money out the door.
Well, there's a lot I could say about that, and so let me
You got 20 minutes to do it. So
I have how long?
You got 20 minutes if
20
you want
minutes.
to.
Okay, so I think between all of the topics proposed here, I think there's this really nice synergy between all of them. So there's foci associated with the development of artificially intelligent systems, focus on how to communicate with these systems, how to train with these systems, how to evaluate trust and performance within these systems. And one way to think about pulling this all together is to think through the processes associated with the foundational knowledge we need to achieve some of these goals, as well as lines of effort within our respective directorates, where we focus on early maturation and testing and evaluation of some of these systems. So what's often referred to as 6-2 research. And then moving and working closely with industry and academia to push these capabilities out not only to industry for further maturation and development, but also push them up to higher colors of money, 6.3, 6.4, and 6.5, for further maturation and test in actual operational systems. My personal opinion is on being able to achieve this is having some stability of the research agenda that's longer than 3 to 5 years. So the challenges that we're talking about here are big. And we've been talking about autonomy for 4 or 5 years now. And we're just now starting to see some seed corn out of that, or some fruit out of that seed corn. And so in order to push really into these capabilities at the level we would like to see them and having a full-on program capable of this, we need to think through the foundational 6.1 research coming out of AFOSR, how to tie it to 6.2 lines of effort across the directorates, and then push those into products across the directorates and through collaborations with companies in order to achieve some of the goals we're interested in seeing occur.
Joe, you've worn both hats. What can you add to that? You've worn both the AFOSR hat and the 7-Eleven hat. What can you add to that?
Well, Peter, as you and Dr. Mayberry were reflecting on that 2012 workshop back in Ocala, Florida, it was making me reminisce a bit about the early parts of my career where I felt like I had to do a lot of convincing to folks to say, hey, trust is a really important problem. We should be investing in it. I don't feel like we have that problem anymore. I feel like everybody acknowledges that trust is an important problem. I think our next step, and we're already doing this based on events like this, coming together as an AFRL team. As Chris mentioned, leveraging basic science. There's so many basic science challenges that we need to address in this field for trusted AI. We need to come together and solve some of these really big challenges for the operators. So I think our next big challenge as a community is taking what we know about basic science and applied science and all the 6.1 through 6.3 all the way up to 6.5, as Chris mentioned, and actually solve some real problems for real people. And we're doing that. We certainly do that in pieces, but I think as a community, we have an opportunity to do this together. And I think if we do it together, we can solve some of the real grand challenges in this space, which would be huge.
So I wanted to throw out there, given Peter's question earlier about continuing this into a type of program, is given that each of the different topics that we just went through are facets critical to the long-term goal which we're seeking to achieve, how do we're going to need some help in integrating these capabilities in a way that can facilitate further research, as well as identify where the gaps are in foundational understanding when we start putting these pieces together. So does anybody have any suggestions on what that might look like or how we would go about doing that? Peter, you?
I've asked enough questions, so let's get some thoughts. Well, let me ask Matt. So as the person who probably is really closely connected with the real applications, what help can the rest of this group provide you in making sure that the technology reaches the field?
Yeah, so I think first of all, what the acquisition community at large needs is a basic understanding of what AI is. I took a class through the JAKE, the Joint AI Center, almost a year ago, and it's very surprising on when you actually learn about how it works and everything. I think our workforce could first use that. That way they could have a better appreciation for when they're buying the next system, writing requirements or whatever that is. What is the foundation of that so you can actually buy the system and get it to the field? So that would be the thing that I would offer up, is an educational campaign for our workforce. And then even getting our contracting community involved too, because they're the ones that are going to be dealing with data rights and intellectual property that is going to be critical for us to make sure that these systems can make it. Does that answer your question?
Yeah, I mean, I think in the spirit of what Chris was just asking, if there's anyone listening in from the powers that be, what help do you think we'd request of the Air Force hierarchy or the Space Force hierarchy to make sure that we can do what we all want to do, which is ensure that this program has a meaningful long-term effect rather than, just has a short-term benefit of doing some good research. Anyone?
I think, so of course we need to identify the right stakeholders in this. So for example, when I came up with the STTR topic on heterogeneous hierarchical planning, the people I had in mind was Air Mobility Command and perhaps Transcom more specifically. And I think one of the things we lack, and maybe have always lacked, is the communication between operators and SNEs. Like I said, I thought I understood the problems in Air Mobility Command, but once I met with operational experts at AMC, once I met with the chief scientist, it turns out I had no idea what I was talking about. So I think it's very important to identify them. For my topics, I have Air Mobility Command in mind, and then for explainable AI and transfer learning, I had Act 3 in mind. They've had some success using reinforcement learning on AFSIM and transferring to a real-life aircraft, which I think is tremendously exciting. And I think my transfer learning topic in particular could improve results within that domain. Now, how do we set up those meetings? Who should be in those meetings? I don't know exactly how that would work, but I would love to meet with as many operational experts as humanly possible. So whoever can facilitate that, that would be great.
Do we need help in doing that, or is it simply a matter of contacting, let's say, the chief scientist from the MAGCOMs and saying, we'd like to come and show you?
I think someone whose name carries more weight than mine would be more successful in doing that. Peter.
Steve, you have any thoughts on that?
I agree. As far as getting out there with the operators, getting to the higher ups, but it does need to be somebody a little bit higher than us working level steps to really broker those types of meetings.
Mm-hmm. Sarah, you've actually been out in the semi-real world before coming to FOSR. What do you see as being things you'd like to see happen? And the same question to Sarah also.
Sorry, did you just say Sarah and Sarah, or what just
I
that?
said Laura, and then after Laura's finished, I wanted to get Sarah's opinion on that topic.
Mm-hmm.
Laura? Laura seems to be frozen.
So I got confused with the Sarah and Sarah.
Sorry.
Yeah,
It wasn't just me. Okay, that's fine. That's good.
No worries. So yeah, I think talking with the operational community as much as possible is very important. Being at shared spaces that is possible would also be very helpful to see what their real-day challenges are, especially in human-machine teaming. But one of the things I was thinking about, which may not quite answer this question, but goes back to a previous one, is kind of, how do we work together for the future? And I think we've got this collaboration started, which is amazing. And, the plan is to continue it. But also, as we go, I think we're going to have to be ready to make some shifts. Because even if we have the roadmap kind of written out where we want to go, if everything works the way that is kind of envisioned, so more intelligent and it can start making their own decisions autonomously, there's going to be more of it. So trust is going to change, essentially. How people interact, how they co-train, the different types of theory of mind and mental models, these things will evolve. But we also have to be ready to pivot for when these things are evolving. Is the research ready so that we can keep moving from the more foundational to the more advanced capabilities for the warfighter? So I totally took that question back a couple steps, but it just occurred to me that that's something we're sharing here at this event today.
I'm sorry, what was your last comment?
Hello? It's just something we should be considering at this event today as we're thinking of trusted AI at scale and towards the future of trusted AI and how we work together. So just something I wanted to throw out there.
Okay, so Sarah, how do we keep the partnership engaged from your point of view?
Well, so Peter, originally, I thought you said originally that coming from the real world, I have some experience that I can, give to this discussion. And I was going to say, well, previous to this job, I came from academia. So I don't know if that actually counts as the real world, but I will say so someone coming from, a very, very basic research background. So for a long time, I was doing research, basically just at the 6-1 level. This has been transitioning into the Air Force and grappling with these questions of how do we actually transition, the research that I just find very fascinating in and of itself to being actually applicable and helpful to someone out in the field. And I mean, I don't know how much more I can add on top of what's already been said. There's already been some really good comments, but definitely, understanding better for me personally, what those transition partners are and what their needs are and how I can best, provide my knowledge in service of what needs to be developed, because, there's a whole lot of work that still needs to be done just at the basic level. And just to be able to help just human teams to be able to be successful. And so then how do we then transition that to a machine on top of that? And so, yeah, to me, I'm so interested in just those basic questions, and then really looking forward to seeing how this transitions forward.
So from your point of view, are there things that you think the next time we do a go round on this, you think could have been done in a way to engender even more collaboration, even more ability to look forward and make it a lasting program?
Well, that seems like a very hard question, especially since I was one of the last people brought on. I don't know if anyone else wants to jump in with their thoughts, but
I just want to give people a chance to
Yeah.
To comment, because I think everyone involved with this process, Brian, Denise, and everyone else who began this is really looking for suggestions from us on how to extend the success. So if anyone would like to use this as a forum to suggest some things that will enable us to do even better the next time, I think this would be an interesting time to bring them up.
Well, I want to jump in and say I think Denise and Bryant did a fantastic job of getting us connected with each other and pulling this together. So I think from an organizational perspective, they've been fantastic. And the way that you phrase that makes me think that we ought to think of this differently. So rather than we have this pitch day, and then the next time we do this, how could we do it differently? My recommendation would be to, so we've had this pitch day and now we've started. And soon we ought to confer again to talk about, to present progress to one another and further open the opportunities for deeper collaboration across the groups. So we have a set of opportunities in terms of SBIRs and SBIRs and STTRs that are going to begin generating output and failures, to be frank, and identifying where we have gaps in our understanding, where we need greater 6-2 investment, things that are making fantastic progress and can be pushed into a phase 3 or directed to a MAGCOM for further push into for the warfighter, I think require us to continually work together as opposed to have another pitch day sometime down the road. And so I look forward to continuing to work with all of you as we make progress on each of the topics that we've put forth and how we can start leveraging each other's output as input into our own research agendas and further trust in human-machine teaming.
Yeah, I mean, I think it would be, I think I agree with that completely. And I think it would be even better if we can invite, assuming there's no reason we couldn't do it, invite the PIs of the various things we're funding to come join us and discuss how it becomes a community rather than a separate set of activities. Any reason we can't do that?
Time and resources. And so we're all very busy, but I think we all want this to occur. And so it requires us to make a commitment and continue down this path.
Okay. In the couple minutes that have left, does anyone else have any questions for your fellow members of this gathering? Surely somebody has something to ask. Going once, going twice. Okay, well, in that case, I suppose there's no crime in ending 2 minutes early. I want to thank everybody, not just for their appearance on this forum, but also for the incredible amount of work I know everyone has put into this, in topic selection, in Ask Me Anything days, in weekly Thursday meetings, in reviewing dozens and dozens of proposals, and listening to pitches, and in making this meeting a success. And at least I personally echo what Chris said about the Herculean efforts that Denise and Brian and the NISTEC and other people involved in this made on the effort. So really thanks to everyone for that. And thanks to our audience. I do want to remind people that tomorrow, the official announcement of the winners will be made. Without revealing a secret, I will say that probably the best part of the pitch day is when we informed one of the people that they had won, not knowing he was still on camera, he jumped up in the air and did a high five. So I think we should focus on everyone tomorrow and see how many people the U.S. government has decided to delight and please. So it was our true view of we're from the government and we're here to help. So anyway, thank you very much, and onward to the rest of the meeting.
Thank you.
And I
Hang
guess
on, everyone, don't leave me yet.
there is Denise. Okay. I was waiting for Denise to read it.
So, Dr. Friedland, thank you so much for being here and really, it's been a great experience with you, and I've learned a lot. So Alvaro, Steve, Joey, Sarah, Lara, Chris, and my favorite, Captain Ruden. How are you? Oh, there's a smile. No, actually, you know what, you guys, I can't thank you enough for everything that you did for this event. This has been by far the best experience that I have had working with each and every one of you. You guys are about the mission, you're about the warfighter, and that's what matters. And as far as the follow-on, I'm in. I want to know exactly what everybody is doing, how we're going to move forward with all of this, and really, really emphasize what it is that we want to do. So again, each one of you, thank you so much. And please keep in touch, and we will reach out again here soon to kind of get things on the way forward. And guys, thanks. Gales, I can't say enough. Thank you so very much.